examples, okay, in the metrology, the measurement and the metrology. Okay, so now this entire chapter talks about how the instruments, okay, are manufactured, okay, and how they are maintained and what are their different types. Keep silence. Okay, so we'll discuss about the standards of the measurement. Okay, how they are manufactured, at what conditions they are manufactured, and what are their different types. Okay. Now, roles of standard in the measurement, material standards, subdivision of the standards, and calibration of the end bars. Okay, so we will learn about after the subdivision one more thing about the end and the line standard. Okay, and then the calibration of the end bars, and we are having two numericals on the calibration of the end bars. So now from this particular chapter onwards, we will have certain theory part and the numerical part, the combination of both. So for this part again, for this lecture, entire theoretical part. Okay, from the next lecture onwards, okay, few theory part and few numerical. Okay, that will be the condition. Okay, and in the fourth chapter, again it requires two more lecture of the unit 1. Okay, that talks about the different transducers which are used during the measurement. Okay, so introduction part about the different transducers. Okay, what is their role? Okay, and what are the functions of each and every transducer? Okay, which are used in the different apparatus and which are useful for the measurement of measurement and the calibration of the equipments. Okay, and then we will start our unit 2. Okay, that is the real application part of the measurement and metrology. Okay, so that has the multiple, in those particular conditions we are having 80% as the numerical part. Okay, so once we study or once we complete one particular theory part, again a numerical on that. Okay, it means our direct application part. Okay, so entire unit 3, 4, okay, we are having a lot of numericals. Okay, so now this will start with the role of standards in the measurement. As we all know that, okay, standard. Okay, why we require the standard during the measurement?
So that there is a uniformity across the globe.
There should be a uniformity across the globe. Okay, we are using certain equipments. Okay, so if we don't maintain a standard, okay, ultimately, okay, everywhere that dimension can vary. Okay, so to have the particular quality of any particular product, okay, the measurement should follow a particular standard. Okay, so a standard is defined as the fundamental value of any known physical quantity as established by national and international organizations of authority which can be reproduced. Okay, so those particular standards can be reproduced. Okay, as and when we are having a requirement, or if we find out that there are certain limitations or disadvantages of certain particular technique which we are using. Okay, then again that those organizations, those bodies, okay, can modify those particular standards. Okay, so those things we will discuss, right? So this is your standard. Now during the measurement, okay, we require the comparison with a known quantity. Okay, and if you are comparing something with a known quantity, okay, that known quantity is manufactured by using certain standards. So that we call it as a standard. Okay, suppose if you are measuring, take a simple example. Okay, we are having a different classifications about the size of the sheets. Okay, A0 sheet, A1 sheet, A2, A3, A4. You must have studied it in the engineering graphics or engineering drawing. Okay, so we are having a standard dimension for the A4 sheet, that is 210 by 297 mm. Okay, so although if you take any particular notebook, okay, every notebook will not have a standard A4 size, but ultimately the size of that particular pages, okay, has been represented at the back side. Okay, if you are having exactly the A4, it should have a dimension of 210 by 297, okay, or 297 by 210, okay, or maybe in the centimeter. Okay, that is the standard. And why we call it as a standard? Because it is defined by a body, okay, organization, okay, national and international bodies are there who define this particular standard. Okay, so if they have defined is 200 by 280, okay, that will be considered as a standard. But they have defined 210 by 297 as a standard dimension for A4 size pages or A4 size sheet. Okay, it can be a page, it can be a sheet, okay, or it can be anything. Okay, that has the actual dimension of A4. So that is ISO standard. Okay, similarly, for the measurements, okay, for measurement apparatus instruments, okay, we are having such kind of different standards, okay. And why we require this standard? So that we can compare it with the other quantities which we want to measure, okay. So for the comparison, okay, during the measurement we require a known quantity. So a simplest example, okay, if you want to measure the length of this particular instrument, okay, what is the particular quantity, known quantity which we will take? Simplest one is a ruler scale, okay, a scale or maybe the vernier caliber, okay, any particular known quantity we will take, okay, for the measurement of the dimension of any particular quantity or product, okay. So for that purpose, okay, we need to manufacture the scale, okay, by following those particular standards. And now in this particular chapter our aim is to understand about those standards, okay. We will not understand how to manufacture the scale, okay, but about the different standards which are used during the measurement and metrology. Necessary to define an internationally accepted value for a unit quantity, okay, and moreover these should be measurable, okay. So internationally they should be the same, okay. If you are considering suppose 1 yard, okay, so 1 yard means how much feet? 1 yard means how much inches? 1 yard means नहीं पता? 1 yard means 36 inches. Means how many feet? 3 feet obviously. 12 inch means 1 feet. Okay, so 36 inches means obviously 3 feet. So 1 yard which is equivalent to 3 feet. So that is, this should be internationally accepted. The conversion should be internationally accepted. Okay, that's why we are having these standards. Okay, so that everywhere 1 yard means 3 feet. Okay, and we are having a defined length for 1 yard. Okay, we'll discuss those particular methods, right? Fundamental units form the basis for a measurement system. So we already discussed those 7 fundamental units. Okay, so that is length, mass, time, temperature, and other 3, okay, which are not generally used for the linear measurements. That is unit of light, candela, okay, then mass, that is number of moles, mole, okay, and last one is the ampere, that is current, okay, intensity of obviously current, for that we use the current. So role of standard in the measurement: globalization, because it is impossible to conduct a trade without the standards, okay. To have a trade between the nations, okay, there should be a standardized practice which has to be followed by everyone. Fairness in trade and commerce: for that purpose we require a quality, we need to satisfy the quality of product, and for to assess the quality we require the accurate measurements, and for the accurate measurement we need to have a defined standard. Accomplishment of complete interchangeability of the manufacturer. So if we are having 2 organizations and they are manufacturing the different parts, okay, and if you want to assemble those particular parts, okay, so we will heard this word multiple times, interchangeability, okay. It means that we are having separate organization, or in a same organization if you are manufacturing the multiple parts, obviously there will be a different operator or maybe a different section or different department, okay, and they will manufacture their own part, okay. Ultimately they should match with each other, so we need to provide certain tolerances, we need to provide a accurate standard or the measurement, okay. So that is again the role of standards. Following the global standards help the manufacturers to convey the quality of their products to the customer, okay. If they follow a standard practice or any particular standard for the measurement, okay, ultimately that will give you the better quality. If they are following certain standard, it means that all the particular products will be of the defined or the specified dimensions, okay, and it is easy to convince the customer that their products are the quality products, okay, if they obviously follow the standard. Ultimately everyone follows this standard, no doubt, okay, but still it is necessary to follow the ISO standards, and it is necessary to use the equipments, okay, which are nationally as well as the internationally recognized. Okay, that part will come in the end and the line standard part. So standard plays a vital role for manufacturers across the world in achieving the consistency, accuracy, precision and repeatability in the measurement, and in supporting the system that enables the manufacturer to make such measurements. If any particular organization is following the specified standard, then obviously they will achieve the consistency, accuracy, precision as well as the repeatability in their multiple products. Okay, so all the things, that is accuracy as well as precision, will be obtained along with the repeatability. If you are saying the precision, then ultimately the repeatability, okay, and the consistency. Okay, all these things can be achieved if they are following the standard. So obviously along with the standard there are multiple other things which has to be followed, but the basic is the standards. Okay, that is the measurement techniques. Now these are the 7 fundamental or we can say the primary units which are used in the SI system. Okay, obviously they are having different units in the metric English system. Okay, so these are the units which we generally use, or we call it as a fundamental or the primary units or primary dimensions. Right. Now the material standards. Okay, we are having, if we are going with the linear measurements. Okay, so we are having 2 particular systems which we use, either the English or the metric. Okay, for the linear measurements. Okay, so if you consider the metric system, it has the 2 classifications, that is yard and meter. Okay, we'll talk about English system later on. Okay, and following the metric system, yard and obviously the meter. Okay, yard is obviously which system? English system. Meter is obviously the metric system, that is nothing but the SI unit which we generally say, CGS and SI. Okay, so it is the same. So yard is equivalent obviously to the English system and meter is obviously the metric system. Okay. The problem with the material standards used earlier was that the materials used for defining the standards could change their size with the temperature and the other conditions. Suppose if we are using XYZ type of the material, okay, and if we are defining a particular scale, that you are defining that earlier. Okay, nowadays we know that. Okay, we are talking about the historical part now. Okay, since from when we have defined that 1 yard is equal to 36 inch. We will discuss the method, okay, from which it has been defined that 1 yard is equivalent to 3 feet or 36 inches. Okay, so earlier, before the invention, the first recognized dimension is obviously the length. Okay, so whenever the trading has started between the nations, okay, the first recognized dimension is obviously the length. Measurement is obviously the length. Okay, so for that purpose they have used the multiple techniques. Okay, and one of that we will discuss about the meter as well as the yard. Apart from that, we are having some other technique, that is the wavelength standard, that also we will discuss, and beyond that we are having the subdivision of the standards also, that also we will discuss. Okay, so the problem with this particular material standard, okay, if you are using XYZ material, then might be possible that we have defined that 1 yard is equal to 36 inches. Okay, if we are having a different temperature, if we take that standard at some other industry and that other industry is having certain different environmental conditions, like maybe increase in the temperature or maybe decrease in the temperature or maybe change in the atmospheric pressure, then ultimately that material will change the shape. Okay, that will change the size, and ultimately what will happen, if any standard is recording 1 yard is equal to 36 inches, okay, might be possible that in some other location that particular material will record 1 yard which is equivalent to 35 inches or maybe 37 inches. Its size might get shrink or might get enlarged. Okay, so you must be aware about the C25 steel. Okay, C25 steel changes its dimension, linear dimension, by 0.3 micron if we change the temperature by 1 degree Celsius. Okay, if you take the familiar example, that is the most familiar example. Okay, C25 steel grade. Okay, that changes the dimension by 0.3 micron if we change the temperature, if that material is brought in the different temperature zone. That is, different temperature zone is different atmospheric temperature. Okay, that changes the dimension by 0.3 micron. Okay, so likewise, if we make a certain particular standard, material standard, okay, so that might change its dimension at a different environmental condition. That is a particular challenge. So in order to keep the fundamental unit unchanged, that is 1 yard equivalent to 36 inch, great care and attention has to be exercised to maintain the same condition. For that purpose, we need to select a certain material that will get affected least by the changes in the environmental condition. So while preparing that particular standard measurement equipment or measurement device, okay, we need to select a material in such a way that it will have a least effect of change in the environment. Okay, that is the perfect solution. Okay, for that, rather than the other going with the other techniques. Obviously, other techniques were developed. Okay, and those provides the more accurate result nowadays. Okay, that also we'll discuss. We'll go with one by one from the historical to the recent and the current stage which we are using. So yard or meter. Now please see the definition carefully. Yard or meter is defined as the distance between the two scribed lines on a bar of metal. Okay, between the, we are having one line. If you want to measure the length of this, okay, we'll take the distance between the two lines, the first line and the last line. Okay, so it is the distance between the two scribed lines on a bar of a metal. Okay, nowadays we are having the glass, maybe the scale. Okay, we are having some different material scales. Okay, but we are talking about the initial phase. Okay, so it is primarily defined as the distance between the two scribed lines on a bar of metal maintained under the certain conditions of temperature and support. Okay, they were maintained under certain conditions. Okay, and then they define the particular distance between the two lines. Okay, now let us go into the historical part. Okay, about the yard and the meter. Okay, so that particular first one is called as the empirical standard yard. Okay, whenever the yard distance, okay, that has been recognized, okay, that it indicates, okay, that has been for that purpose this particular material has been followed. The material which consists of the three elements. Okay, we'll come back to the figure. Okay, it consists of the three elements which is having 82% copper, 13% zinc and 5% zinc. Okay, so that for this particular bar which is used, okay, to accurately measure a distance in yard. Okay, so obviously likewise a different experiment has been carried out. Okay, and this was considered as giving the most accurate result for a yard. Okay, so as you can see the construction of this particular equipment which is called as Imperial standard yard. Okay, this is a particular round bar, okay, which is having 1 inch as a diameter. Okay, this is having 1 inch as a length. Okay, this is the obviously the which view, as we already studied the engineering graphics, front view, top view and obviously side view. Made with the different materials, ultimately if we take them under different conditions, okay, they will affect the most. Okay, it doesn't mean that this particular instrument, if you are taking it from either from 0 to 5, okay, that will also change the dimension, but with respect to the other materials, that change will be very less significant. Okay, so now the challenges with this, the material standards are affected by changes in the environmental condition such as temperature, pressure, humidity, aging, and that will obviously result in the change in the length. Okay, change in the dimension. That is the major disadvantage of these particular material standards. Okay, we are talking about the historical part. Okay, don't correlate these things with our scales. Okay, recently we are using the scale and various other instruments. Okay, that is a technological development which has taken place. Okay, we are talking about the 80s. Okay, these instruments were invented in the 80s. Okay, so preservation of these standards is difficult because they must have appropriate security to prevent their damage or the destruction. So that's why that is one more challenge. Replicas of the material standards are not available for use at the other places. Okay, we need to make that particular specific material and at that condition itself. So if you want to measure certain distances, okay, in the industry or in the workshop, okay, so we need to take that particular specimen over there, and might be possible that there will be a change in the atmospheric condition. Okay, so we'll not be able to use that. Or if you make a replica, okay, again if you take the replica at other particular place, that will ultimately change the overall length of the product. They cannot be easily reproduced. okay, that requires specific conditions, okay, which we already discussed. Comparison and verification of the sizes of the gauges possesses the considerable difficulty, okay, that has the specific conditions. That's why the comparison and the verification of the size of the gauges which are used, okay, that is again a challenge. While changing to the metric system, a conversion factor is necessary from yard to meter and meter to yard, okay. So again, in those particular days, okay, that again that has also become a challenge to use these particular material standards. Now, to solve these particular difficulties, okay, one more standard which was invented is the wavelength standard. Now, wavelength standard is just it is not a physical quantity, okay, it is just a theoretical concept, or we cannot manufacture it in terms of a physical instrument, okay, but obviously it provides you more accurate result than the material standards, okay, which were imperial yard, okay, or the meter standard, okay. So the wavelength standard, so obviously by considering the different disadvantages of the material standard, it has a specific need, okay, so that we need to find out a particular instrument or a device, okay, which should not be affected by the environmental conditions, okay, because those material standards get affected by the environmental condition as they changes its length, okay, either decrease in the length or increase in the length. So it is necessary. So during the 11th General Conference of Weights and Measures, it was held in the Paris in 1960, okay, so new standard of length was recommended, which is the wavelength standard, okay, to measure the size or to measure the linear dimension of a product, okay. So by using the wavelengths of a monochromatic light as a natural and invariable unit of the length, the dependency of the working standard on the physical standard can be eliminated, okay. So it means that we have to use the wavelength standard, okay, and to use the wavelength standard, obviously a monochromatic light, okay, as a natural and invariable unit of the length has been defined. And what was it? According to the standard, a meter is defined as 16,50,763.73 of the wavelengths, okay, which is having the red orange radiation of a krypton 86 atom in a vacuum. We all know that whenever you consider any particular machining operation, okay, which considers the wavelength, okay, you must have studied during the physics, the first year as well as in the 11th and 12th, okay, they has to be kept in the vacuum. Why? Remember the sources of the light we are using, okay, that has to be kept in the vacuum. That you will also study in the 6th semester whenever you will study about the different machining processes, different non-conventional machining process. Maybe it is a electron beam machining process, laser beam machining process, okay, ion beam machining process. Why? Vacuum में क्यों maintain करना होता है? If it has interaction with the atmospheric air, okay, the light beam will not get focused on the particular application point, okay, that it is a possibility to get it diverted, okay, from its defined path. That's why a vacuum environment has to be maintained. So this standard can be reproduced with the accuracy of about 1 part in 10⁹, okay, and can be accessible by to any laboratory, okay, provided they should have this particular material, okay, or we can say a particular gas, okay, krypton 86 atom, okay, and that has to maintain a particular vacuum chamber, okay, and then they can measure the particular length of the object, right? But obviously it cannot be manufactured, okay. If you want to measure the length of a particular product, okay, you need to keep it in that particular laboratory and then only it can be manufactured. So it obviously we are saying that to neglect the disadvantages of the material standard, this is one of the particular process, but again we have to maintain the vacuum, again that becomes the same. Ultimately we are saying that take the entire setup at the other industry, okay, or set up the same particular kind of the apparatus in other industry and use it, okay, but it is equally the same, okay, it has to be maintained, this particular condition has to be maintained at the specified conditions. Okay. So another modification has been done in 1983. So this modern meter was defined in 17th General Conference of Weights and Measures. Okay. So now instead of using this red orange radiation of krypton 86 atom, okay, they have used certain different light sources. Okay. So it is not given. Okay, so they have used certain different atoms, okay, of the different elements, okay, and they have defined that the accuracy, okay, was improved with the other source, okay. And what was the accuracy? The meter is the length of the path traveled by the light in vacuum during the time interval of 1 by 299,792,458 of a second, okay. So out of this particular 1 second, this is the particular time, okay, during which we can define the meter dimension. Okay, so the reproducibility of the modern meter is found to be 3 parts in 10 raised to 11. Earlier it is 1 part in 10 raised to 9. Okay, so 3 parts in 10 raised to 11, which could be compared to the measuring the Earth's mean circumference to an accuracy of about 1 mm. Okay, so that particular thing we can use it to measure the circumference of the Earth with an accuracy of 1 mm. Okay, so again it is not a physical instrument. Again we are having the same limitation, that it is not possible to manufacture it, okay, as a physical instrument, just like which we have the scale or the vernier caliber, okay, or any particular slip gauges. Okay, we will discuss that within the 8 bars. We are having multiple slip gauges which are nowadays also used in the industries. Okay, slip gauges and the end bars. Okay, but they are used only for the products, okay, which needs to be manufactured in the multiple batches, multiple quantities. Okay, so slip gauges are more accurate than the scale which we are using. Okay, that part we will discuss. So now, by considering all these things, now we are having this sub-division of the standards. Okay, now we are having the master standards aren't accessible in the routine use. Okay, the standards which we have discussed, whether it is material standard or the wavelength standard, okay, those cannot be used in our day-to-day activities, either in the workshop, in the laboratories or in the industries. Okay, so that cannot be used. So for that purpose, again some certain modification or the developments has taken place. Okay, and as per those particular developments, what are the different standards? Okay, those were invented. Okay, and those were nowadays those were also present. That has been divided into 4 different categories. Okay, that is primary standard, secondary standard, tertiary standard, and working standard. Working standards are those which we are using right now. Okay, working standards are those which we are using. Okay, like the scale, vernier caliber, all those things. Okay, working standard are of the 2 types: line standard and the end line bars and the end bars. Okay, line and the end standards. So that classification we'll discuss once we cover all these 4 points. Okay, so now let us come to the first part, that is the primary standard. So primary standard is nothing but the material standard. Okay, primary standard is nothing but the material standard which we have discussed. Okay, so obviously again the primary standards cannot be used. Okay, they obviously they get preserved, okay, in a particular atmospheric condition, not the atmospheric, under specific environmental condition to maintain their same length. Okay, and they usually, okay, they usually the manufacturer or maybe the any particular body, organization body, okay, they take out of those particular instrument from the specific location, okay, once in a decade or once in a 2 decade, means in 10 or 20 years, okay, वो एक बार निकाला जाता है प्राइमरी स्टैंडर्ड. Okay, which is nothing but your material standard जो हमने डिस्कस किया है. Okay, so now what is the use of the primary standard? Okay, for defining the unit precisely, that precisely defines the unit. Okay, preserve carefully and maintain under the standard atmospheric condition. Atmospheric condition in the sense water may be the requirement, just like for the imperial yard. Okay, 62 Fahrenheit is the standard condition. Okay, for the meter 0 degree Celsius and 1 atmospheric pressure is the standard condition. No direct application in the measurement. Okay, used only for comparison with the secondary standard. So it doesn't have any direct application. We cannot use the primary standard for the measurement of any particular product. Okay, because ultimately that will change the average, and it obviously to make the primary standard. Okay, the cost required is very high. Right? Then what is the use of the primary standard? It is used as a reference for the secondary standard. जैसे मैंने बताया कि the international bodies, okay, they use it once in a decade. Okay, organization bodies. So it is used for the comparison with the secondary standard. Now what is secondary standard? Obviously secondary standards are the specimens or the apparatuses which are derived from the primary standards. Okay, now secondary standards are also not used in the day-to-day life or day-to-day measurements. Okay, secondary standards are largely used for the calibration of the instruments. Okay, you can say generally आप बोलते हो ना, is the first copy, second copy. Okay, secondary standard equipment जो है, that is the first copy of the primary standard. Tertiary जो है, that is the first copy of the secondary standard. And the working standards है हमारे, okay, that is the first copy of the tertiary standard which we are using. Okay, so now the secondary standards obviously resembles closely to the primary standards with respect to the design, material and the length, but they are used only for the calibration purpose. Now calibration which we are saying, not the calibration which we are doing in the laboratories. Okay, precision applications, all the precision, whatever may be the equipments, okay, which are used for the precise applications, okay, for performing the calibration of those particular equipments. Okay, just like suppose if you are having any particular laser machine or anything, okay, which is highly accurate, which has to be used for the precise application. Okay, so calibration of those particular equipments, we are using the secondary standards. They are also preserved obviously, okay, kept under the supervision at the various locations. Okay, unlike the primary, okay, they are available at the multiple locations, okay, but not as that of the working standard. Used for comparison with the tertiary standards. Okay, safeguard against loss or disruption of the primary standards. Okay, obviously if you are having primary standard, okay, which is lost or maybe any destruction has taken place, maybe changes in the length or maybe wear, in which generally does not take place. Okay, so that is a obviously considered an alternative. Right? The tertiary standard, it is the primary and secondary standards are the controls for the standard, while the tertiary standards are used as the first standards of reference in workshops and the laboratories. It is the replica of the secondary standards and used for references for the working standard. Okay, not exactly the scales and vernier calibers. This is not the tertiary standard. So वो क्या होगा? Can you tell me practically what a practical example of a tertiary standard? क्या practical example हो सकता है tertiary standard का? Gauges. Okay, it means that the devices, okay, which are used for the inspection of the components. Suppose you have done the measurement, you have completed the measurement by using the working standard, okay, and if you want to do the inspection, and for the inspection a highly precise instrument we will use, okay, that is your tertiary standard equipments. Okay, so that those are used for the inspection purpose. Okay, and you can say they are the copy of the primary and the secondary standard. Okay, they are obviously for the inspection. We use the equipment, inspection equipments in all the laboratories, in all the workshop. Okay, so that's why it is written over here that they are used as the references for the working standards, and they are used, okay, in the workshop and the laboratories, but only for obviously for the inspection purposes. Why don't we use it for all the measurements?
बहुत यूज होगा तो वेरिएंट है.
Very good. Okay, if you are using it continuously, okay, there will be a wear and tear, okay, and ultimately that will add the cost to the measurement. Okay, wherever it is precision is required, that time they are used as a they are considered as a regular use. Okay, otherwise we are using the working standards. So now all the measuring instruments we are using more frequently, those are the working standards, low grade as well as the low cost. Okay, as compared to obviously the tertiary. We cannot compare the cost of the working standard with the primary and secondary. Derived from the fundamental standards. Okay, working standards include both line and the end standards. Okay, which we need to discuss about the line and the end standard. Okay, so what will be the equipment which we are using? Okay, those falls under the working standards. Okay, now there are certain errors which are associated with those equipments. Okay, which we will discuss with the line and the end standards. Okay. In the industry generally we are having, suppose you want to manufacture this particular product, okay, and you are having this as a, suppose 50 mm as a length, okay, so we want to manufacture this product, okay, in the multiple numbers, 1000, 2000, maybe 5000, okay, इस numbers में आपको manufacture करना है, okay, so to accurately measure, okay, the dimension of this particular product, that is for the inspection, okay, we manufacture the gauges. Now what is that particular gauges? Okay, by using the standard technique, okay, or by using the secondary standard technique, okay, we manufacture the certain blocks or certain bars which has a length of, or which has a height of 50 mm or maybe 40 mm, 30 mm, 12 mm. It depends on the requirement. 1 mm, 2 mm, 3 mm, 4 mm as per the requirement. So starting from 10, 20, 30, 40 as per the requirement. Okay. Their end surfaces are highly polished. Okay. Their end surfaces, it means the top surface as well as the bottom surface as well as the side surfaces. Okay. They are highly polished. Okay. And we just keep it with the, we just take a reference, we just compare it with the our quantity or our product. Okay. And when we check it, okay, whether we are having any particular error or not. अब वो error check करने के लिए सबसे easy way क्या है? To check whether we are having any light which is passing or not. अगर छोटा सा भी 0.2 mm का भी अगर suppose light pass हो रहा है, वो error आपको line standard से कभी detect नहीं होगा. Okay?
Fitting जो हमने जैसा किया.
Exactly. You use that particular T scale. Okay, आपने वो particular flat surface के लिए T scale use की थी. अगर कोई भी light pass हो रही है, it means that the surface is not flat. And obviously, the slip gauges on the end bars, okay, they are manufactured in such a way that it is having exactly the flat surface. Okay, this one has a flat surface. Obviously, top and bottom they are highly polished surfaces. So if you are observing any light which is passing, it means that it is not an error of the slip gauge or the end bar. It is obviously the error of the product which you have manufactured. Okay, so comparison of the dimension with the any known quantity, okay, precise known quantity, that comes under the end measurement. Okay, so when the distance between the two flat parallel surfaces is considered a measure of the length, it is known as the end standard or the end measure. Okay, ये 50 mm है suppose, अगर आपके पास 40 mm का ही ब्लॉक अवेलेबल है, slip gauge or any particular end bar, okay, you will keep 10 mm above that. अगर आपको 51 measure करना है, you will keep 40, then 10, and then obviously 1. So whenever you are using multiple slip gauges, okay, that is a particular some sort of, we can say, a limitation. If any of the slip gauge has an error, ultimately that will result error in the final inspection. Clear? So we are having some more particular parts about the line and the end measurements. Okay, their characteristics, the differences that we will cover in the next lecture. Okay.